Using a renewable energy source, such as wind power, we can electrolyze salt water in a 4-chamber container. From each chamber, we get a different byproduct with endless uses. Chamber 1 releases pure oxygen. From chamber 2, we get sodium hydroxide. Chamber 3 produces hydrochloric acid. And from chamber 4 comes hydrogen. In this video, we're going to follow hydrochloric acid and its use in mining. For this example, we're going to use olivine, the world's most common mineral. When you crush up this worthless rock and dissolve it in hydrochloric acid, you get magnesium chloride, iron 2 chloride, and salicylic acid. Salicylic acid, when you heat it up and evaporate off all the water, you get fumed silica. This is the material that computer chips are made of. So you can sell this off to Google and help fund the rest of your operation. The magnesium chloride that's produced can also be heated up, but it's got to get to a molten temperature. When you electrolyze the molten magnesium chloride, you're left with two products, magnesium metal and chlorine gas. The magnesium is worth about $3,400 a ton, so this can help fund the operation. But the chlorine gas is also important. Chlorine gas is extremely toxic, so you can't just release it into the air. However, you'll need it in the next step. When you combine chlorine gas with the iron 2 chloride you got from the olivine, you get iron 3 chloride. At this point, sodium carbonate and water are added to the iron 3 chloride. These are also both byproducts of the system, but we'll cover where they came from in the next video. This combination of sodium carbonate, water, and iron 3 chloride produces ferric hydroxide. And when you put ferric hydroxide in a dryer and cook off the water, you're left with pure hematite. Hematite is the ore that's used to make iron, and it's usually very expensive because it has to be mined using explosives, huge trucks, and grinding mills. But since in the 4C process it's all coming from the rocks under our feet, it can become much cheaper. This means that iron could potentially replace lumber as a building material. So all those oxygen-producing forests that would otherwise be turned into houses could be replaced with iron and keep giving off oxygen.